So this week we're covering promissory moats. I promise to build this ring of water around your building. No, promissory notes, simple discount notes, and the discount process. So this is going to help us set the stage for next chapter a little bit. So compounding interest and in present value slash discounting is in chapter 12 is going to be kind of the step up. This is the introduction. So if you feel like you're good with this, that's good, because that's going to kind of set the stage for everything else. So for chapter 12, we'll talk about the fact that when you have simple interest, it's nice because then it's just basically, okay, it's a proportion of the total for the year. However, in reality, banks aren't that nice. And also, if you have money in the stock market, it could be compounding sooner because of the fact that the growth rate may be updated daily, continuously. So we have some different equations. So instead of the Hert equation, P equals E to the RT, or it could be some time component like you're familiar with. And then discounting will will help you understand present value, which will be important for chapter 17 when we talk about depreciation, because the value of the dollar in 2021 dollars is going to be different than the value of a single nominal dollar in 2027. And so using the discounting process and present values will allow for us to understand, okay, we can forecast out the value of something or how much we're willing to pay for it now based on how much it'll be worth in the future. Because that's something that firms and banks are going to be interested in due to the fact that there's going to be inflation in the economy. So this sounds like a lot, but really there's really only one calculation. Just like last week, there's really only one calculation with a couple modifications based on the number of days, or is it months, or are we trying to find time? Are we trying to find rate? Are we trying to find the principal? So it's really one equation. Each week I'm trying to give you like one equation to work through and really feel like you feel good about it. So maybe it feels a little bit slower paced, but honestly, I want you to understand it more so than just try to bog you down with like 6,000 math problems. Like when I took math back in the day, I took 2 math courses. One was once a week like this one, and there was one assignment every week. I actually give you more work than that class, so I'm sorry about that. But the other math course I took in undergraduate was 4 days a week, and it was an hour a day, and you would have a homework with about 20 problems every single night. And mind you, I was working full time while doing this and taking other classes. So like maybe if you're a full-time student, that's great. We're okay. Like we learned about this calculus thing, and then you have to do 20 problems related to it by 9 a.m. tomorrow. Well, if you've got a job or you've got kids or you've got even another class or another project to do, there's just no way you're going to get it done. So I did the best I could, and I understood the value in it because there's a lot of learning that happens when you're just constantly day after day getting it drilled into you, kind of like for a language, you're getting all that information drilled into your mind. I see the value in that, but we have to live in more practical times. So anyways, we're going to basically differentiate between what we talked about last week and what we're talking about this week. Really, the big difference between last week's material and this week's material is that last week's material was focusing on calculating how much interest is if the amount of money you're getting is the face value. What's going to happen differently here is instead of you getting the full amount and then you paying back the full amount plus some amount, the amount that you borrow is not the amount that you receive. The interest is already deducted from that. And so you'll receive some proportion of the total that you said that you were going to borrow, but essentially the interest is already deducted from it. So the total amount that you pay back is just whatever the face value is. So like, let's say that you take out a $15,000 loan. Last week it was that you would get $15,000, and then based on the interest rate and the amount of time it took you to pay it back, you'd pay 15,000 plus whatever the interest was. What's going to happen tonight, or what we're talking about this week, is that you'll pay back 15,000, and so they deduct the interest or calculate the interest that you would generally pay back from that 15,000. So you're paying back 15,000, but then after they discount that interest, you're only receiving 14,000 something. Does anybody have a question? Okay. And then we'll calculate these things with treasury rates and the steps of the discounting process. So what does a promissory note look like? So, I mean, it's not going to look exactly like this, but standard, when you have a promissory note, what it's going to say is this is how much you're going to borrow. So I might have said, we said principal last week because we had our equation that was like I equals PRT. Principal is just your face value of the amount that you're borrowing. And then the amount of days in which you're borrowing it, the amount again here, just like with the check. The annual interest rate. So again, interest rates are always annual. So like you have the chapter 10 quiz, and the chapter 10 quiz might say, okay, chapter 10 quiz will say, okay, I have a 60-day loan. Well, that interest rate is not based on the 60 days. It's based on an entire year, based on whether it's ordinary interest, exact interest, or simple interest. So if you have like a 60-day loan and it's at 9% interest, it's not that you have to pay 9% on it every 60 days. That 9% is for the whole year. So I just wanted to clarify that. I feel like you know that already, but I just wanted to clarify that. So if you see a question that written the way I just described it, you'll understand the difference. And then maturity date. I mean, we've already kind of addressed all these terms, but I just wanted to clarify that the maturity date is the day that you pay it back. And so we're used to paying things back incrementally over time, like a car loan or a mortgage. But when it comes to promissory notes or bonds or treasury bills, there's one day in which everything is paid back all at once, interest included. So if I borrowed like $20,000, I would pay back the $20,000 if it was a discount, or I'd pay $20,000 plus the interest rate if it was a standard loan, all on December 1st date, 2020, which is in the past. So clearly not when I'm paying it, or else it's super past due. So this is just reminding you. So like maybe if you're taking out a car loan, this is kind of what the top of it looks like in a way. If I remember correctly, I don't remember the last loan document I had because I swear when I signed it was all like electronic on an app instead of like the old school carbon copy printer. So a few years ago, I was still using they were still using the carbon copy printer. I had to wait for it to make the loud noise and then I would sign it. But now I think I signed on an iPad. It was back in March and I was ready to get out of there, which is probably exactly where they wanted me in that moment. But in terms of the song and dance of buying a car. Anyways, getting back to what we're focusing on today, which is a simple discount, just some terminology that's important. So when you have a simple discount note, this is different than having a loan. This just means that the interest that you're paying on the loan is deducted in advance. So the big difference between a standard loan and a simple discount note is that the bank is going to take the interest out up front. So you're saying that you're borrowing $15,000, which you technically are, but what they're going to do is instead of you having to pay $15,000 plus some interest over time, $15,000 is how much you're actually paying them back. And what they're going to do is they're going to take a discount, and the bank discount is the interest that they deduct in advance. If you ever take macroeconomics with me, we'll talk about the discount rate. And the discount rate is the interest rate that the Federal Reserve charges banks to borrow from them overnight. And a lot of people get confused by the term discount, being like, oh, what is the benefit? Like when we think about discount, senior discount, or like student discounts, we're saving money somewhere. What it's saying is discounting in a way is basically depreciating the value of something up front. So that way, when the time comes, it'll be equivalent to the number that was in our heads. So if we wanted to borrow 10 grand, you discount it, then that means that when I pay everything back, it'll be 10 grand. But what I actually receive is less than 10 grand. Because if you pay back $10,000 to the bank, the actual purchasing power of that $10,000 is going to be lower in the future. And so as a result, instead of giving you the full value of the 10,000, they're giving you the value of what that 10,000 will be forecasted in the future, and then you pay them back the 10,000, and then the amount that you received and the amount they received is essentially the same in value based on their estimates, minus whatever profit margin they decided to factor in. So the bank discount rate, so now you know the little secret that a lot of my econ students don't know, is that discount rate is meaning that we're discounting the value of it because we're deducting the interest up front. So you're still going to pay it back on a certain day, but we're discounting the interest up front. So the amount you actually get is less. If only that was the case with student loans. So like if you ever borrow a student loan, typically what they'll do is they'll charge some administrative fees, so you still don't get the whole amount that you borrow, but they still charge the interest anyways. It's annoying. Anyways, so again, the discount is the dollar value that they're discounting, and the discount rate is the percentage of interest. So that's why when we're calculating the dollar amount, the discount rate is factored into the equation. So this should look like the Ippert's equation to you, because it is. The difference is that this money, instead of adding it on to the principal value, it's going to be subtracted to the principal value, and that's going to turn out to be your proceeds. So the face value, which is the principal value, is going to be your maturity value. Now, before, your maturity value was interest plus principal. Now your maturity value is proceeds plus interest. So that's really the only difference that's happening here, is that we're taking the interest up front, which means the money that you get is less. The amount you pay back is equivalent to the face value, instead of the money that you receive is equivalent to the face value. So let's just say hypothetically you borrow 10,000. It turns out that the bank discount is $250. Well, then that means that your proceeds are going to be the amount that you pay back, which is going to be the 10,000 minus the 250 in interest that they deducted up front. And so your actual proceeds are going to be $9,750. So just as an example, I guess I did the I guess it was in my head that the same example was the case, but now you have the math and the actual scenario behind it. Basically, if Terrence borrows $10,000 for 90 days from Webster Bank and they discount the note at 10%, what proceeds does Terrence receive? And we're using ordinary interest calculation here. So the difference between what we did last chapter was, okay, you borrow 10,000, you have a 10% note and you pay back in 90 days, then the total amount of interest that you would have to pay is going to be $250, which is what we've already calculated at the bottom. Now, if this was last chapter, then the amount that Terrence would pay back in 90 days is $10,250 because he would get the full 10,000 and then he'd have to pay back the $250 in generated interest from that. What's happening now is that the 10,000 is not what Terrence receives. He's going to receive whatever is left over when we deduct this interest from the initial 10,000. So we've already calculated that the interest is going to be $250. So if we deduct that up front, that means that Terrence will receive $9,750, but he will pay back 10,000. So the difference, so chapter 10, he received 10K, he paid 10,250. In chapter 11, he's going to receive 9,750 and pay 10,000. That's the difference. Which of these seems more appealing to you? Go ahead and chat. Which would you prefer? Would you prefer the first format where you get all the money up front and then you pay back the full amount plus the interest? Or would you rather just pay back whatever you said you were going to borrow, but the actual amount of money that you receive when you borrow it is less? Which seems better for you? Or better to you? So Amanda says she would prefer the second one. Any other thoughts? When I was looking at this, it seemed simpler to me to be like, okay, like Bethany says the same. So when I was looking through this, I was like, okay, this seems more convenient to me to be like, okay, like I'd rather just know that if I'm borrowing 10 grand, that I'm paying back 10 grand rather than paying back 10 grand plus interest. For those of you who chose the second option, unfortunately, the problem with that is that the actual effective interest rate, meaning the real interest rate of the money that you're borrowing, is higher in the second one. So if you end up taking the second route, because it's simpler in terms of how much you pay back, there's a premium that comes with that. And the premium is that the amount of money that you're getting, if you take the amount you're paying in interest back, they've deducted, and divide that by the amount of money that you receive, then the actual interest rate is going to be higher than this one. And I'll show you in a second. So let's do a second example where you're going to borrow $14,000 at 8% interest over 60 days. We'll use ordinary interest since that's what the banks like to do. So we'll use 360 as our date calculator. So if we want to calculate the interest, it's going to be the same because the equation is exactly the same. It's a $14,000 loan in both cases. Yes, in the second option, in the simple discount option, you're receiving less, but the actual amount of interest in terms of the dollar value is the same. So if you do 14,000, which is your principal, times 0.08 times time, which is the 60-day loan with ordinary interest at 60 over 360, the amount you're going to pay in interest is the same, which is $186.67. Here's where the difference is coming. Remember, you get the full 14,000 in a simple interest loan, but in the simple discount note, you do not get the full amount, but the 14,000 that you're borrowing is the final total that you pay back. So the maturity value for a simple discount note is just whatever you said you were borrowing. And then for simple interest, it's whatever you said you were borrowing plus the actual interest that you're paying back. So this one, you're technically paying back more money. So it might look like on its face that it's a better option because, okay, in this one, I'm only paying back 14 grand. This one, I'm paying 14,186.87 back. But again, the trade-off is that the proceeds are just whatever you said you were going to borrow in the simple interest note. But in the simple discount note, you're actually paying the interest up front, which means that what's left over is only $13,813.33, which you might not seem to care about. But if we actually determine what the true interest rate is for these, for the simple interest note, it's going to be 8%. Because if you take our equation, our IPRT equation, and if P is 14,000 and I is 186.87, then to get R, we divide this by 14K times the 1/6, because 60 over 360 is 1/6, and you're left with 8%, which is what we would expect because the interest rate is 8%. However, if you receive a simple discount loan, the actual principal that you're receiving, the proceeds that you're receiving is lower because we've already deducted the interest. So if we know if you're giving away 186.87, or excuse me, 186.67 of the principal value that you were that you said you were going to borrow and you signed to borrow, well, what's left over is 13,813.33. And if we multiply that times 1/6, it turns out that we end up getting 8.11%, which means that the actual amount of money that you're paying back, or excuse me, the actual effective interest rate that you're paying back is higher. Because the proportion of the amount of money you actually receive is higher when the interest is deducted up front, because you're only getting what's left over. So yes, it's more convenient that you only pay $14,000 back, but it's a higher interest rate. So technically, the simple discount, because it's easier to determine how much you owe. but in a way it's actually worse because of the fact that the effective interest rate is lower. So the actual value of what you're getting in terms of the loan is diminished. This is why, this is also why like some people are try to determine whether they should have all of their stuff taken out before taxes or after taxes for their like health insurance and stuff like that. I always do pre-tax because then what happens is if you're going to be charged the same amount for your health insurance and all that stuff anyway, and then your taxes are based on what's after the pre-taxed, like healthcare and benefits and stuff like that, then the effective tax rate is lower for you. So it's kind of like the simple discount, but backwards, where you're kind of like loaning yourself out money, or you're basically loaning the government money in the form of taxes. So if your taxable amount is lower, then you pay fewer taxes. And you're going to pay that $100 and some a week to health insurance anyway. So you can kind of use these principles in that regard as well. So this is just kind of like a one-page summary of all the differences. So they're the same here. You're going to borrow something for less than a year. You're going to pay it back all at once, but the difference here is that you're going to pay back whatever the face value is. Here, you're going to pay back the maturity value. So here, you're paying the interest on what you're going to pay, not the amount you're borrowing, and this is you're paying based on what you're borrowing, which means that if you borrow 14,000, then you pay back 14,000. If you borrow 14,000, then you pay back 14,000 plus the interest. The difference is that you'll receive the 14,000 if you're paying 14,000 plus the interest, but if you borrow it 13. But if you do it up front, then you're getting less, which means your effective interest rate is higher. This is the common way in which it's done these days because you have to know the rate of interest and it's not 100% clear. If the interest is deducted, technically your effective rate is higher. So it wasn't accurate. So personal loans and things like that may still use this simple discount note option. I would also suggest, I'm just trying to think about this, you would probably not want to do that also from the perspective of the highest value of the money that you're going to receive is the moment that you receive it because of inflation. So if I take out a car loan for $20,000 today, it will never be worth $20,000 again in terms of how much $20,000 is worth today. Just like if I got a loan for $20,000 10 years ago, the value of $20,000 today is substantially lower than the value of $20,000 10 years ago. And then 10 years from now, that $20,000, or 5 years from now, that $20,000 will be worth a lot less than it is right now. And so if you take out the interest up front, that means that the 186.67 that you're not getting today is worth more, the 186.67 that you're foregoing to not have to pay back the interest later is worth more than the 186.67 that you're going to pay back over time. So it's in your best interest, even though nominally it looks like it's more money. Like it looks bad. You're like, man, look, I'm paying an extra $200, but in reality, you're actually paying less. Technically, you're supposed to be paying the same amount, but in this one, you're actually paying less. So even though the numbers look worse and ugly, you're actually paying less on the left-hand side than the right-hand side. So I also agree in that the one on the right seems a lot simpler, where it's like, well, I just get a random number deposited in my bank account. Whereas, and then I pay back a round number versus, oh, I pay back this weird number, but I have a round number in my checking account. Like, I don't know what you would prefer, but I would prefer the uneven number being in my account because it's easier to just think about, oh, I pay back 14,000 instead of 14,186.67. But that's how they get some money out of it. So just as a reminder, the effective rate is just the amount of interest that you pay in dollars divided by the proceeds, which is the actual amount that you receive times time. So for example, again, if you, let's say you borrow 10,000 and you deduct $400 off front on a 60-day loan. So if it's 400 times 1 divided by 6 times 10,000, oops. So you're paying $400 back and you're paying it in 60 days. And that means you're going to receive $9,600 because $10,000 minus 400 gives you 9,600. Then your proceeds will be, or excuse me, not your proceeds, your effective rate will be 25%. Whereas if you paid it back all at once, you'd have 10,000 times 1 divided by 6, 400 divided by that gives you 24% as your effective rate. So when you discount, it's more expensive. This is 25% versus 24%, where you're not discounting, you're just doing interest, simple interest. So that's why the chapter 10 calculation is cheaper. But if you go that route, then they might compound, and then the compounding can get pricey depending on how frequently they compound. Daily, quarterly, annually, things like that. Now, what about treasury bills? So I'm not sure how familiar you are with treasury bills, but basically when the government borrows money, they issue a bill or a bond called a treasury note or a treasury bill or a treasury bond or T-bills. Now, this says that it could be 4 weeks, 13 weeks, or a year. They can actually be longer than that. You can have a 2-year bond, a 5-year bond, a 10-year bond, because the federal government tries to spread out their debt over a longer time horizon, so that way they're not paying back a big chunk of interest all at once. So the difference here is that instead of the proceeds being given to you, the proceeds are being given to the government. So maybe your grandparents gave you a savings bond and it said it's going to be a $500 savings bond on a certain date. So let's say that you're 10 years old and for your birthday, so today's my mom's birthday, so happy birthday to her. Let's say that my grandmother had given her a savings bond 40 years ago, and it was for 10 years. Grandma paid an unknown amount that we're trying to figure out. And then in 10 years, on the same day, they agree to pay $500. So this is a savings bond. It used to be a popular birthday gift, Christmas present. Does anyone have any of these anymore? Has anyone ever gotten one? When I was younger, I got one and then I cashed it in when I was like 16. But anyways, so the question that we're trying to solve here is, how much did Grandma pay for it? Neat. I should have held on to mine. Because the thing is that it matured on my 18th birthday. I didn't want to sit on it anymore. And then I didn't understand at the time because the bank was like, oh, it's a $500 savings bond. Oh, it's worth $414 today. And I was like, cool, I'll take $414. I don't care. And I didn't really think about at the time why it was $414, because technically, just like all these other notes, the US government is going to pay me $500 on the date of maturity. On my 18th birthday, I cash it in. US Federal Reserve gives me $500, or the Treasury Department gives me $500. Cool. But I didn't understand why it was worth only $414. It was because it hadn't matured yet. So what was happening was the bank was offering me $414 to buy it now, and then the bank would get $500 for it on the date of maturity because they have no qualms just sitting on it because they're going to make $85 in profit off of it, essentially. I didn't realize that at the time, but that's how securities work, is that you have a promissory note. You can sell that promissory note to somebody else if it's the right financial instrument, and then the person will pay back whoever's holding it the date of maturity. If it's a long-term outlook type bond, they try to get them at a low price, because about your grandparents, my grandparents were notoriously cheap. So I figured if I was going to get $500 on my 18th birthday, that my grandma did not pay something close to this if I had to sit on it for like 10 years. So the question was how much did she pay for it? Well, I don't know how to figure it out because I don't know what the interest rate was on it. But if you knew the interest rate on it, you would be able to figure out, and you knew how long it was going to take to mature, you would be able to figure out how much it cost Grandma. So for this example, so what'll happen is for this one, if you take out a $10,000 13-week treasury bill at 4%, basically the federal government will pay you $10,000 in 13 weeks. So 91 days from now, or 13 weeks from now, the the federal government will give you $10,000 in exchange for that money right now. So the question then is, how much do you pay them for the opportunity to get $10,000 in 13 weeks if they have chosen an interest rate of 4%? Well, it's the same old calculation. It's just that it's from the perspective of you buying the asset instead of you getting lent the asset. So the federal government is acting like you in the regard where they're saying, well, okay, 13 weeks from now, we'll give you the full maturity value. But you're not giving them the full maturity value, you're giving them a discounted value. So you want to figure out, okay, well, if I'm paying them, if they're paying me back in 13 weeks out of 52, if we do simple interest, and it's at 4%, and it was 10,000 that they're paying me, then that means that the discount that I'm providing them is $100. So essentially, it's kind of like what your net gain is going to be. So you are going, so what you've determined is you're going to pay them $9,900 right now, and then in 13 weeks you're going to have $10,000. And then to calculate the effective rate, remember you take the proceed amount, not the original stated loan, and so the actual effective rate is 4.04%, which means that the actual amount of money that you're receiving in terms of proceeds is higher than the stated interest rate. So for you, it's a good deal. The question is, so like some people might want, well, why wouldn't I do this? It seems like guaranteed money. The federal government will pay me back. Well, they're worried about the debt ceiling and defaulting on the debt right now, so maybe not. But it's also small incrementals, and 4%. If you were getting 4% in the 13-week Treasury bill right now, you should put your entire life savings into it, because that's easy money, and that's not a very long time to wait for a 4% return with minimal risk. These days, it's fractions of a percent. If you want to hold out for 2 years or 5 years, you're probably looking at 2 to 3%. But if you had a 13-week Treasury bill right now, you'd probably be paying. The interest rate would probably be like 0.3% or something like that. I haven't looked it up recently, but it can't be that high because interest rates are still in the floor. So the step-by-step process is you want to calculate the interest and maturity value of the simple interest note. You want to calculate the discount period, how long they're going to hold the note. You're going to calculate the bank discount, and then you're going to calculate the proceeds. So if you're trying to determine how much, so basically, if you know the interest rate and you know the maturity value, which is the for a discounted, it's just whatever the face value is. But if you have the face value of the loan, you're actually going to get that. Then you can do the Ippert equation, calculate interest, and then add that to determine the maturity value. If you're going to determine the discount period, so if they're holding it for 60 days, 90 days, whatever, you can then calculate the bank discount, and then you can calculate the proceeds by subtracting the principal amount, excuse me, the bank discount value from the principal amount. So like our old example with the 10,000, was it? I think it was 0.25. And it was 10%. Because it was 90 days over 360 with ordinary interest, so you have 250. So your maturity value in the simple interest world is 10,250. If you want to do the simple discount, then you would already have calculated the 250, so then you subtract that from the amount that you're paying back, and you're left with that $9,750. So any questions about that? So if you want to discount something prior to maturity, so let's say that someone borrows $2,000 and they promise to pay back in 185 days. The interest rate is 6%. And then at a certain point, the bank decides to discount it at a different rate. We now want to calculate the total amount that they have to pay. So if they're going to pay the whole thing back in 185 days using this traditional simple interest calculation, that would generate them $61 in interest, which would mean that the total they would have to pay back is $2,061.67. That's the maturity value. Now, what about the bank, though? The bank has decided, you know what? On August 9th, we'll give you 2,000, well, we'll give you 2,061.67 is the total amount that you have to pay back. The discount is 5%. That's how much you're paying the bank back for taking out this at the 6% interest rate. You're going to pay that back in 31 days, which means that the amount of interest that the bank is collecting is only $8.88. So how much are you getting back in return? Well, you're getting $2,052.79. And so the reason why there's 31 days left is because we were calculating the difference between March 8th and August 9th. How much time has elapsed between there and 185 days? Well, between March 8th and August 9th, 154 days had elapsed, which means that the discount period is 31 days. So you can go through the whole rigmarole like we did last week. Well, there's 30 days in April, 31 days in May, 30 in June, 31 in July, 9 in August, and there's only 23 days left in March, so it's 154, and then 185 is the length of the loan, so you go in and discount it for 31 days. So just to clarify what this is saying, this is basically the example where this is the example of where I was talking about the bond earlier, where I sold it early. So you're getting $2,000 in 185 days. They're paying you 6% interest, which is why you need to know the maturity value, because that's how much the person that owes the $2,000 is actually paying back. They're actually paying this amount back. However, you decided to sell it with 31 days to go, like me, because you're like, I need the money now. You're selling it to JG Wentworth. You need to have an annuity and you need cash now. So you call them, and then you get your payment, which is $2,052.79. And then they're going to get that extra $888 for sitting on it for another 31 days. So let's do another example. Unfortunately, I have all the answers already listed here, but if we wanted to calculate the bank discount for something that was $6,000, discount rate's 3%, and you're paying back 160. Let's say we're doing ordinary interest again. Technically, this is wrong because the interest rate is not 3.5%. So I guess I can't even rely on the darn problem. So technically, it's actually $80. So I wish I could like erase this slide right now. Get out of here. The actual answer is $80. So ignore this calculation right here because it's 3%, not 3.5%. So we calculated our interest. Oops. Interest is $80 because we multiplied times time, 160 over 360 times 3% times 6,000 means $80. So the proceeds, again, remember, this is how much you have to pay back, not how much you're getting anymore. So you subtract the $80 from 6,000 and you get 5,900 and $20 is the proceeds. And the bank discount is $80. So 80 and 5,920. Any questions about that? So if we calculate the discount period for the bank to wait to receive its money, if they have a 45-day note, and it's being discounted on May 2nd, then the amount of days of the discount period is 20. If you're wondering what on earth we're getting with 122 and 102 when the note's only 45 days, that's just because May 2nd is the 122nd day of the year and April 12th is the 102nd day of the year. I think in this case, it was probably easier to be like, okay, well, 18, there's 18 days after April 12th in April, and there's 2 days in May. So 20. I feel like that's easier than what the book convey. And so here's one of the bigger problems that you could do. Let's say that you have a $50,000 loan, interest rate is 11%, the length of the note is 95 days, and then the note is discounted on July 18th. So we want to know what the discount period is. Well, if there's 20 days at the end of June and there's 18 days in July, well, then that would be 38 days is the discount period. Well, actually, it's not discount period, it's not 38 days, it's 95 minus 38, which would be 57. I'm not gonna memorize that July 18th is the 199th day of the year. I don't know about you, but I feel like my way's easier. So I guess that's why I'm the teacher, not the book. So we need to figure out what the maturity value of this loan is, though. So if they're paying this back in 95 days using ordinary interest rate's 11%, borrowing 50 grand. well, then you're going to end up getting 1451.39. Add 50,000 to that, and the total maturity value is 51,451.39. We now know the discount period is 57 days. And if the discount rate, which they didn't even tell me, which is, oh, it's up here, 9%. Sorry. If you have a 9% discount rate, well, then you take the maturity value, multiply that times 0.09 times the date, the period of the discount, then it's 733.18. And then you subtract that from the total amount that you would receive back or you would pay back as the maturity value from that 733.18, which they're taking off up front. And the total amount you would receive is actually 50,718.21. Step one is to calculate the maturity value. So just like last week, then the discount period to convert how much the proceed or the bank discount is going to be, and then the proceeds is just the difference between the maturity value and the amount that the bank is taking. And then lastly, if the Treasury Department auctions 21 billion in 3-month bills in denominations of $10,000 and a discount rate of 4.695, so 3-month bills are the 13 weekers, 91 days. What would be the effective rate of interest? So again, remember I equals PRT. So P is going to be 10,000, R is 0.4965, and time is 1/4. So if we calculate all that, we know that the discount is going to be $124. So if each Treasury bill is 10,000 and the discount is $124.12, then that means that the amount of each of those Treasury bills that you're paying for, so you're going to receive for every single one you buy, you're getting $10,000 in 3 months. But you're going to pay $9,875.87.5 to be able to get $10,000 in 13 weeks. So even though your interest rate is 4.965%, the actual amount of interest that you're generating based on the amount you've actually paid out is 5.03, because remember, you factor in the proceed value, not the face value, to determine the effective rate. So does anybody have any questions related to that? Oops, I tried to erase with, you could see the number. There you go. So 5.03%. So does anybody have any questions?